So this is the concept map of the factors and multiples lesson, in which till now we have seen that what are factors and what are multiples. Factors are associated with divisibility. When we divide any number, we get to know the factors. And in multiples, when we multiply two numbers and we get multiples of the product of the number. So till now we have seen this part. Now today we will get to know, and yes, we have also completed in another video that what are prime numbers and composite numbers as well, and with divisibility rules. So today we'll get to learn what are prime factorization, HCF and LCM, and the relationship of HCF and LCM. So the basic thing before starting HCF and LCM, we should know listing of factors. Now listing of factor means if you have any number, for example 18, then you can list out in which table does it appear. For example, it appears in 1 into 18, that means 1 18s are 18, 2 9s are 18, 3 6 are 18. That means factors of 18 are 1, 2, 3, 6, 9, 18. So this is what the method is, listing of factors. So before beginning of any sums or before solving any other question, we need to understand how these factors are supposed to be found out. So factors of 24 are, one more example, factors of 24 are 1 24s are 24, 2 12s are 24, 3 8s are 24, 4 6 are 24. So the factors of 24 are 1 2 3 4 6 8 12 24. That means this number 24 can be divided by number itself. This number can be divided by 2. This number can be divided by 3, 4, 6, 8, and 12. So this is how we get to know the factors, okay, list of factors, that this number appears in which table. Got it? So if you know this method, then you can find out methods to find HCF. Methods to find HCF, we have almost, we can find out from this listing of factors method also. So there are total 5 methods. One is listing of factors, prime factor tree, prime factorization method, long division method, and repeated, or it also called as short division method. So in listing of factors, if you want to find out the HCF of 18, so which is the highest number, HCF of 18 and 24, so which is the highest number? So which is the, in this pair 18 and 24, if you want to find out HCF, so you will see which are the factors that are common in both the numbers. So one is common, one will be common in every table, so no need to consider this. Then next is 2 is common, 3 is common. Is there is no 4 number over here in 18, but there is 4. So we will not consider this number. Then 6 is common. 8 is there? No. 8 is not available in 18. 12 is there? No. 24? No. So here we have 6 is the highest number which is common in both the factors. So 6 is the HCF. That's it. So same way we have prime factor tree. Prime factor tree, in this we have, instead of listing of all these factors, what we do is, suppose we have number 36. So 36 is divided by 2, we will get answer 18. Then 18 also can be further divided by 2, we will get answer 9. 9 is again divided by 3, we will get answer 3. So 2 2s are 4, 4 3s are 12. So this is how we get HCF of prime using prime factor tree. Then prime factorization method. This is a tree method. See, it's a canopy. And always remember the answer that we get, the remainder, we have to divide that. So this is how the factor tree method goes on. Next is prime factorization method, in which we have very easy. You can see here, it looks like a short division method only. Where we use this number is 36. We divide this by 2. 2 18s are 36. Then we draw the L-shaped line, and 2 9s are 18, and then 3 3s are 9. Okay, so here which we got 2 2 and 3, these are the numbers for HCF which are commonly divided. Now here again, if you put 3 also, it will be considered in LCM. So here we have to consider only these factors which are common. Okay, so 2 2s are 4, 4 3s are 12. It's like that. Next is long division method. In long division method, we have 30 as a number. They will give you, find out the HCF of 18 and 30 in using long division method. They'll give you two numbers. So small number will be outside and big number will be inside. So you can divide 18. You can divide 30 by 18. 18 ones are 18. Either you can write this quotient on top or on the right side. 18 ones are 18. You will get answer 12. Okay. Now this new remainder will be the divisor, and this previous divisor will be dividend for the new next step. So 12 ones are 12. So in this case, we got 6 as the remainder. So now 6 is the divisor, and this previous divisor will be forwarded or promoted to dividend. Now this will be divided, 12 will be divided by 6. 6 2s are 12. So there is nothing left in the remainder, right? So here the last number that we got as a divisor is called as HCF. So it's very easy. I find this one is more easier while solving bigger numbers. So long division method is always like helpful. I feel like that. Okay, let's go for the repeated or short division method, in which you see there's a prime factorization method where we solved at a time only one number, right? 36. So here we have short division method where we can divide at a time two numbers, 24 and 36. If you wanted to find out HCF of 24 and 36, you can simply use same prime factorization method by for short division method. So in this case, same L shape, or you can draw a straight line and a horizontal line, then you can start dividing these numbers. 2 12s, and you have to separate this number by comma. 2 12s are 24, 2 18s are 36. So this is the common number for both. Both these can be divided by 2. Then 2 can divide to 6 are 12 and 2 9s are 18. Again, this is the common number for 12 and 18. Both these number can be divided by 12. Now here we have 3. 3 6 are 12. 3 2s are 6. 3 3s are 9. So in this case, we got all these common numbers for till here. But here the number varies. 2 and 3 are not divisible by common number. So hence, the numbers that we got, we will leave this calculation over here, and the numbers that we got over here can be multiplied. 2 2s are 4, 4 3s are 12. So HCF is 12. So if you ever, if there is a question that asks, find out the HCF of 24 and 36, you will consider this one. 2 2s are 4, 4 3s are 12. So 12 is the HCF for both 24 and 36. So this is not supposed to be counted in HCF. Got it? So there are some example story sums, or you can say word problems, where we can find out. Yes, in every sum they might, in the question they will mention which method you have to use. Listing of factors, prime factor tree, prime factorization method, long division method, or short division method. Now, if they ask any of these methods, then you will have to, you are supposed to use that number on that method only. But if it is not mentioned in a question, then you can use your own choice, whichever you feel easy. Mostly people do in short division method or long division method. This one is quite lengthy, so this is not considered. But for the knowledge purpose, we should know how the prime factor tree is used, and prime factorization method is also some people prefer to separate both, because most of the people find it difficult to find out the common numbers. So they do it separately. So 36 separate and 24 separate using prime factorization method. So it's up to you, completely your choice, if it is not mentioned in the question. So there is three baskets of fruits contain 42, 98, and 70 pieces respectively. What is the highest common number factor of fruit that can be taken from all three baskets at one time? So you can find out using any of the methods, and you will get to know which is the HCF, which will be the highest number. Same we find it greatest number that is divisible by 20 and 48. The question can be easier like this, which is easy to understand. But in this case, you have to see what is the highest common is written. That means you have to find out HCF. Same way we have Aradhya has two ribbons. This is the example that I have introduced in my first video in the introduction itself. So here also we are optimizing resources. That means how many pieces of the ribbon should be cut so it's of the same length without any wastage. Find the largest possible length. So again, it is largest possible length is asked, so you can use HCF. So it's completely up to you which method you are using. So here we have methods to find LCM. Here we have total 4 methods. 3 of them you already know. There is one number line method, very easy, where one person jumps from one place, how many jumps and how at what interval it is jumping. The person is jumping from one position to other. At that time, we use LCM. For example, it starts from 0 till 23. Oh, sorry, it's 0, and it steps ahead by 3 steps. 0, 3. Then after again the 3 steps, 1, 2, 3, it will jump to sixth step. Then it jumps in every 3 steps, 1, 2, 3. Then 6, from 6 it will reach to ninth, from ninth it will reach to 12, and from 12 it will reach to 15. In the same way, there is another person who is jumping after every fifth interval. So 0, 1, 2, 3, 4, 5. So it takes 5 steps ahead. It will start from the 0 position, it will reach 5, then 10, then 15. So after how many jumps this person is reaching at the position after 3 jumps? And what about the first person? How many jumps it is taking? 1, 2, 3, 4, 5. So this person takes 5 jumps to reach at the same position at the same time. So LCM is supposed to be solved when we wanted to know that any event that occur again at the same interval or at the same time again. Okay, so this is how we could find out LCM through number line, which is very easiest method. And in grade 1, grade 2, we get to learn all these how skip counting numbers we use in number line. So this is how the LCM was done. Then next is listing down of multiples, which is very easy. There is you have to find out multiple of 4. That means you will write the table of 4, and they will ask you how many numbers you have to write. 3 numbers, 6 numbers, how many multiples you have to write? Up to 6 numbers, up to 8 numbers, then you have to write till 8. For example, 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 six are 24. So there are total 6 multiples of 4 has been written. Then multiples of 6, 6 ones are 6, 6 twos are 12, 6 threes are 18, and 6 fours are 24. Multiples of 8, 8 ones are 8, 8 twos are 16, 8 threes are 24. Now if you see each number has 24 in this table. So they have stopped there, and these are the common ones which at least they reach at the 24th position where they are meeting all at the same time. So number 24 is the LCM. So wherever they meet at first point will be considered as LCM. Same way prime factorization method, no change. It is same, but only one thing is when we solve this, for example, 36 number, if we have to find out LCM, 2 18s are 36, 2 9s are 18, 3 3s are 9. Now at this position, these are the HCF that we know, right? So we multiply all these number, but we will not leave this number also. We will use this number also. So 2 into 2 into 3 into 3. 2 twos are 4, 4 threes are 12, and 12 threes are 36. So these are the factors of 36. We will write it down like that. And next, common division method for more than one number. 24, 36. We have 2 twos, 12s are 24, 2 18s are 36, 2 6 are 12, 2 9s are 18, 3 twos are 6, 3 threes are 9. So in this case, we have used this full L shape, like LCM. Remember this, that we have to consider this L shape. So 2 twos are 4, 4 threes are 12, 12 twos are 24, and 24 threes are 72. So LCM is 72. So they will reach at the same time where there is a number 72. So here we have some story sums. Find the least number of saplings that can be arranged in rows 12, 15 or 40 in each row. See, don't get confused. It has asked for the arranging in the rows. It doesn't mean it is asking for divisibility. It means it is asking for the least number of saplings. So in this case, we will, whenever it is mentioned least number, that means we have to find out LCM. And if it is asked highest or greatest number, we will say HCF. Okay. Find the lowest number that is exactly divisible by 18 and 24. You will find out LCM by using any of the method that you find it easy to solve. So mostly in this common division method is useful and easy also, because these are a little bit lengthy. These three are little bit lengthy. So this is the easiest method, common division method, to solve all these questions. Bus route A arrives at its stop every 15 minutes. Bus route B arrives at its stop across city every 40 minutes. If both buses are at the same stop now, after how many minutes they will arrive at the same time? So you have to find out 15, 40. So the answer you will get is 120 over here if you solve this. So last topic, relationship of HCF and LCM, where you can find out HCF and LCM both at a time, and you will multiply both these numbers. So the number that we will get is called as relationship of HCF and LCM. The product of HCF and LCM of two natural numbers is equal to the product of two numbers. Take an example. If you say 24 into 36, so 24 into 36 is 864. The product of two numbers is 864. But if you find out the HCF and LCM out of it, so here we have already know that this is the method of finding out, short division method. So 2, 2, 3, these are considered as common factors for finding out HCF. So 2 2s are 4, 4 3s are 12. HCF is 12. But in LCM, we use this full L shape. 2 2s are 4, 4 3s are 12, 12 2s are 24, and 24 3s are 72. So in this case, we are using all these numbers, and we will multiply it. So we will get the LCM as 72. Now, if you multiply 12 multiply by 72, you will get the answer 864. So if HCF and LCM, after multiplying HCF as LCM, we get the same answer as the answer of product of this 24 into 36. That means they are the relationship of HCF and LCM is true. So this is how they ask the question: verify the relationship of the following pairs. By sometimes they give this product of two numbers is equals to HCF and LCM. That means if you multiply these two numbers and if you multiply HCF and LCM, then you will get the same answer as 864 for 24 into 36 also, and 72 into 12. That means your answer is correct. HCF and LCM, both the answers are correct. Got it? So this is how we completed our lesson. And I have given this summarized form so that you can go through this during the exam time. Thank you so much.